Oh yeah. I can see your screen. Oh my God, I love that presentation.
So can I
Where
start?
did you get those? I love that presentation. Oh my God, the graphic is awesome.
Oh, thank you.
And just by the way, Oliver, as you know, everyone should know that I'm recording your presentations in case if you need to have a copy of it to make a portfolio if you apply to better school and you need this kind of extracurricular activity, I can provide you with a copy of your presentation then. Yeah,
Okay,
please go on,
thank you.
Oliver. No problem.
Hi, I'm Oliver. So my presentation is about radioactive decay in cancer. So the first thing is I want to talk about is that what is radioactive decay? To know about radioactive decay, we need to have some base. What is nuclear reactions? Sometimes atoms are not happy just being themselves. They suddenly change to a complete different atoms without any warning. This mysterious transformation is one of the type of element into another in the basis of nuclear reactions, which cause one nucleus to change into different nucleus. Just like chemical reactions cause compounds to turn into other compounds by swapping their electrons, nuclear reactions happen when the number of protons and neutrons in the nucleus of an atom change. Some types of nuclear reactions can actually kick protons out from nucleus or convert them into neutrons. Since we know what to call element by looking up its number on periodic table, then reading off its name, when the atom number change, so does the name of element change. This makes the nuclear reactions look somewhat like mystery. An atom of potassium can suddenly, unexpectedly transform into an atom of this only sign anything has changed in the release of radiation. There, in radioactive decay, there's three types of radioactive decay. The first one is alpha decay, the second one is beta decay, and the third one is gamma decay. Alpha decay is so during the alpha decay, a nucleus actually breaks up into two chunks, a pair of protons bound by a pair of neutrons, which is a collection of four particles, which is essentially a helium nucleus and is called alpha particle. And another pieces of constituting the original nucleus minus this chunk. So this is alpha decay. The second one is beta decay. In beta decay, one of the neutrons in nucleus suddenly change into proton, causing an increase in atomic number of an element. Recall the name of an element is determined by its atomic number. Carbon is carbon because it has an atomic number of 6, while neutron is a neutron because it has the atomic number 7. That means that a reaction that changes the numbers of protons in nucleus change what element we actually consider the nucleus to be. This makes beta decay a great example of how nuclear reactions can easily transform one substance into another. The third one is beta decay. During gamma decay. The third one is gamma decay. During the gamma decay, the nucleus emits radiation without actually changing its composition. We start with nucleus with 12 protons and 12 neutrons. and we end up with a nucleus with 12 protons and 12 neutrons, but somehow radiation get released along the way. So we have some basics about what is the radioactive decay. So let me introduce about some about cancer. So what is the
Oliver,
cancer?
sorry to interrupt you.
Cancer is, yes?
So, sometimes I don't know the quality of the sound. Sometimes get, I should say, convoluted, and we could not hear you so well. Sometimes it
Really?
happens. In case if you are using the microphone, I don't know, maybe rotate it or.
Is it better now?
Please talk and let's see.
Hello? Is it
Hello.
better?
It's good now. It's
So
good. Thanks.
I think there's something wrong with the internet, maybe.
I think so. I think there's something wrong with the connection. But no worries. It's not that bad. We can understand still.
Okay, thank you.
No problem.
So now I have a question. What is cancer actually? The type, the disease that result when the circuit changes cause the uncontrolled growth and division of cells. Sometimes some types of cancer cause rapid cell growth, while other causing cells to grow and divide at a slower rate. Certain form of cancer result in visible growth called tumors, while others, such as leukemia, is not. Some of the body cells have a specific function and fixed lifespans. While it may sound like a bad thing, cell death is part of natural and beneficial phenomenon called apoptosis. A cell receives instruction to die so that the body can replace it with a newer cell that functions better. Cancerous cells lack back the components that instruct them to stop dividing and to die. So as a result, they build up in the body using oxygen and nutrients that would usually nourish other cells. Cancer cells can form tumors, impairs immune system, and cause other changes that prevent the body from functioning regardlessly. Cancer cells may appear in one area that spread via the lymph nodes. These are the clusters of immune cells located throughout the body. So how we use how the scientists and doctors to kill cancer cells. Normally, they use radiation therapy. So, what is radiation therapy? Radiation therapy uses waves of energy such as light or heat to treat cancer and other tumors and conditions. The form of radiation used in cancer therapy is high energy type known as ionized radiation. Um, Actually, the scientists still do not know exactly how radiation works as treatment, but what they do of cancer cell in a way that disrupts their growth and division. In this way, radiation can kill cancer cells, preventing or slowing the spread of disease. Sometimes a doctor prescribes radiation therapy alone, but usually they recommend it in combination with other treatments such as chemotherapy, surgery, or both. Now we know the base of radiation therapy. Let me introduce to you the. We learned this before, but so the exponential growth and decay. So we use exponential growth and decay to describe and measure the radioactive decay and the growth of cancer cell in real-world applications. We need to model the behavior of a function in mathematical modeling. We choose a familiar general function with prototypes that suggest that it will model the real-world phenomenon we wish to analyze. In case of rapid growth, this is the exponential growth function, and you can see the growth when the E0 is equal to the value of time 0. E is equal to E is the Euler consistence, and K is a positive constant that determines the rate of growth. We may use exponential growth function in applications involving double the time is takes for a quantity to double symbols and naturally exhibit growth based on doubling time. But in this situation, we use the exponential growth function to model the division of cancer cells. On the other hand, if the quantity falling rapidly towards zero without ever reaching zero, then we should probably choose the exponential decay model. So this black line shows the exponential decay. Again, we have the form AO, but it's more one minus sign here, a negative sign, and A0 is also the starting value, and E is Euler constant. Now K is a negative constant that determines the rate of decay. We may use this exponential decay model when we calculate half-life or time is taking for a substance to exponential decay to half of its original quantity. We use half-life in application involving radioactive isotopes. So in this situation, we use exponential decay to subscribe the radioactive decay because we know that this is dividing the protons, neutrons, and transferred into another substance. So that's how it happens. That's all for my presentation. Thank you for listening.
Awesome. Thank you very much, Oliver. Fantastic. Great job, man. Great job. Great job.
Thank
Thanks
you.
a lot. Thanks a lot. And although we had some, I should say, some problems, I should say, Oliver, with the connectivity of the internet, but it was good. It was in a way that you could understand. And I love the slides which you had, especially the one that you talked about, I should say, the different type of the radiation of the radioactivity, and you talked about the gamma ray, and that you said that the nucleus doesn't change in terms of its number, but the energy has been radiated in terms of the photon. And it, I should say that was very interesting. And also the details which you had to talk about, for example, the cancer itself. It was very informative. We talk about, for example, how the cancers originates and it changes to a tumor of the body. And everything was great. Thank you very much. And especially the model, the detailed explanation which you had on the model itself, that you talked about both the decay and the growth in terms of its exponentiality, it was commendable. Thanks a lot, Oliver. Wonderful job. Wonderful.
Thank you, sir.
Thanks. And by the way, as I said, in case whenever you plan to apply to different schools, which they require extracurricular activity in order to beat the competition, you always can present these presentations to them. That you can ask a copy from me.